Welcome to another segment of High School Geometry with Netz and Weichel. This is Mrs. Netz.
And this is Mrs. Weichel.
And today we are looking at 6.5 Indirect Measurement. This lesson is so cool and so easy. Seriously.
Are you ready for it?
Yeah. Well, check this out. By the end of the lesson, we are going to be able to use proportional reasoning and apply those properties of similar triangles to solve problems involving measurements. So, like, we'll take a small triangle to measure something that is so big, we don't have anything to measure it with.
Hence the indirect measurement. You can't directly measure it. It's too big.
This is the coolest thing ever. So, indirect measurement is a technique that is used to find measurement when direct measurement is not possible due to the size of an object. So you can't exactly get out your measuring tape and measure the height of a mountain. So you can use something like indirect measurement. How will you know that you know how to use indirect measurement? Well, when you can set up a proportion correctly, finding a missing measurement.
All right, so let's go ahead and get started. So as we just discussed, indirect measurement is when you can use similar triangles and measurements to find distances that are difficult to measure directly. So they're too big to actually measure. So we're going to use indirect measurement to figure out the actual height of something or the distance across something that is not directly measurable. So the key thing to remember is the fact that we're using similar triangles to do this. So within any real life situation, we're going to create two triangles, and they are most of the time going to actually be two right triangles based on the fact that we're dealing with height of objects that are too big to measure.
And like in previous lessons, when we were dealing with similar triangles, I would highly recommend drawing these two triangles separately so that way you can see them individually. If you'll notice in the picture that we're getting ready to do, there's actually two triangles there.
There are actually two triangles. So you guys have some fill in the blanks. Please make sure you're filling them in. I know I've walked around in class and some students think they don't need to fill in these blanks, so make sure you're filling them in. It's setting up the problem for you. So you have a 2.5-foot fire hydrant that's casting a 4-foot shadow. The shadow that is caused by a streetlight that is 28 feet away from that fire hydrant. You're figuring out approximately how tall is that street light. So we're going to go ahead and label everything and get everything set up. So the first thing that I'm seeing is the street light with the actual light itself is creating a triangle. And then the fire hydrant here is creating a triangle.
So we have a big triangle and a small triangle.
We know that the fire hydrant is 2.5 feet tall. And we know that the shadow caused by the light is 4 feet in length. So you can see I don't have enough room on my screen to have everything there, but you guys have some room above your picture. You could draw this separate, but I'm doing this so you guys can see the two triangles. So that's one of them. The other thing is we know that the fire hydrant is 28 feet away from the light. So from here to here is going to be 28 feet. So we're going to use segment addition to figure out that the bottom of my triangle, this big triangle right here, is going to actually be 32 because I'm going to add 28 and 4 together to make that 32. Notice I put X along the side of the street light because that's what we're looking for. We're looking for how tall is that street light. So we can go ahead and now set up a proportion. So the top of my fraction here, we have the height of the street light over the height of the fire hydrant. So on the top, I have my street light. On the bottom, I have my fire hydrant. In the second ratio here, we have our 32, which is the distance the light is from the fire hydrant plus the shadow. That's making the entire bottom triangle. And then we have 4, which is the shadow of just the fire hydrant. So what I'd like you to notice is that both numerators we have are the light. It's coming from that light triangle.
These are both from the big triangle.
And then if you look on the bottom, the 2.5 and the 4 are both coming from the fire hydrant.
Or your small triangle.
So I think students have an easy time with these. What I notice though is students think that they're having an easier time than they actually are. You need to make sure you remember what this symbol means, equals. if you're going to do big triangle over little triangle here, you can't switch it up in the next one. You want these fractions to be easier, so equal. They are the same. So if I decide that big is going to go over small, then I always have to have big over small in the entire problem.
One of the ways it'll help you get this set up is if you always keep it set up like a box. So Mrs. Weichel is written off on the left. Light is up in our numerator. Fire is in our denominator. We could also set up two columns. Our entire left side of our equation is talking about the height of both objects. So this column is 100% talking about how tall things are. Then on the right side, our right side is talking only about the shadow and how long that shadow is. So on the left, we have how tall the object is, and on the right, we have how long the shadow is.
And then once you set it up, you're simply going to go through your cross multiplication process. So the first thing we get is that 4 times x is going to be 4x. 2.5 times 32 is going to be 80. We're going to use the division property of equality by dividing 4 on both sides, and we end up getting that x is 20. One more thing we want to mention, because these are word problems, you want to answer your word problem with words, so we expect to see a sentence to be written for our answer. So the question is approximately how tall is the streetlight? Our answer would be that the streetlight is about 20 feet tall.
Perfect. Let's go ahead and try another one.
All right, so our next one, this one hopefully is a little bit more clear with what the two triangles are. So inside light, a cactus is casting a 9-foot shadow. At the same time, a hiker has a walking stick that is 6 feet tall and it's casting a 4-foot shadow. Use similar triangles to find the height of the cactus. So we have two triangles here. We have our cactus height that we don't know, so I put x there. A shadow for the cactus is going to be 9. And then our walking stick is 6, and our shadow is 4. So we're going to go ahead and set up, I set it up the same way as I did with the streetlight problem. I'm going to go ahead and do our big triangle on top, our little triangle on bottom. My first ratio is going to be height, and my second ratio is going to be shadow again. So my two heights are going to be x and 6, and I did big over small. And then my second ratio is going to be shadows. I did big to small, so 9 to 4. From here, we cross multiply. So we have 4 times x is 4x, and 6 times 9 is going to be 54. And from here, you just solve the equation. We use the division property of equality to divide 4 on both sides, and we end up getting an answer of 13.5. So the cactus is 13.5 feet tall.
Perfect.
All right. So now we're not talking about height. We're going to talk about the distance across something. How long is the lake? So again, hopefully you guys can see your two triangles. If not, I'm going to go ahead and highlight them to separate them out. So the first triangle that I'm seeing is right here, this little triangle with two side lengths of 40 and 120 right here. And then my larger triangle is going to be, this problem is going to be similar to the streetlight problem in that you have triangle ACE, this large triangle. We don't know how long AC is yet, but we can just use segment addition to go ahead and figure it out by adding the two together, and we end up getting
482 meters.
482 meters. So there are our lengths. So I, again, did big over small for my numerators and denominators. For my two ratios, I did vertical sides and then I guess hypotenuses.
Yep.
So I'm going to go ahead and say that D to 40 is the same as 482 to 320. Notice the 162 is not used by itself because it by itself is not part of a triangle. It's part of a trapezoid, not a triangle. After you've set it up, you're going to go ahead and cross multiply again. So we're going to do right here, we have 320 times D, and we have 40 times 482. That's going to give us 320D is equal to 19,280. we're going to apply the division property and divide 19,280 by 320, which gives us 60.25. Elizabeth wants to know the distance across the lake. Well, the distance across the lake is 60¼ meters.
Not too bad.
Not too bad. Again, hopefully you're seeing how easy these can be. If there's one thing we really need you to just understand, we keep talking about it, is the consistency and how you are setting it up initially. You want to stay consistent. Again, I've done big over small every time. I've done vertical or heights with horizontals or hypotenuse. Like, I'm keeping my, as Mrs. Nett said, like a box. Make sure you're staying consistent in your rows and your columns with your proportions.
So why don't we have them try one and see how they do?
I like that idea. So let's go ahead and let you guys try this one. We want to know, can a buoy float 62 meters from the shoreline? All right, so hopefully you guys see your two triangles. Your first triangle is right here with the 3 and the 5. So your distance out to that point W, and then the depth. Your second triangle is going to be 62 and D. Hopefully you didn't get 65. You didn't add the 3 and the 62. Hopefully you noticed that I am giving you V to Y. You didn't need to figure it out.
Hopefully you're also noticing that this problem is very similar to the one up above, almost like a reflection of the triangle, but pretty much the same thing.
Pretty much the same thing. So my ratios are going to be big to small, and depth, and then distance out. So you can see that's how I set it up here. We have D to 5 would be the same as 62 to 3. And then from here you will cross multiply. 3 times D and 5 times 62 gives me 3D equals 310. 3 is going to get divided out, giving me 103.3 repeating. I forgot to add my repeating line.
Or we could say 103 1/3, because like we said, when we give you words or give you a word problem, you would answer back in words. And we're answering a question about a distance, and you need to keep in mind when you're answering questions like these, how would you speak? What would you say to somebody? And if you measured something, you wouldn't say, oh, it's 103.33333. You would say, it's 103 1/3. So with this problem, they're asking us, is it possible that this buoy could be 62 meters from the shore? Because a buoy has to have 100 meters of depth. Well, when we did the math, we found that out at 62 meters, the depth is 103 1/3 meters. So since 103 1/3 is greater than 100, we know, yes, the buoy can be 62 meters from the shore because the depth is 103 meters and the buoy only needs a depth of 100.
I like what Mrs. Nett said. I had issues typing the 1/3, so that's why I have it as a decimal, which I know is not a good excuse.
Well, yeah, no.
Sorry. All right, so there you go. All right, the last problem we have is going to start out at a very easy problem. Hopefully you guys can clearly see the two triangles. You can even see where the X is right here. We're looking for the height of the tree. So I'm going to ask you guys to just go ahead and find the height of the tree. All right, so we have our two triangles. We have a height of X and a height of 5, and then we have like a shadow, I guess you could say, of 7 and a shadow of 14. So if I say with consistency how I've been setting these up, this is going to be my ratio. We have our heights on the first ratio, our shadows in the second. On top I have my big, on the bottom I have my little. From here you are going to, shocker, cross multiply, and you're going to get 7x is equal to 70. Divide the 7 out and you end up getting that x is 10. Now, this is where this problem takes a little turn. You're not quite done yet. The question isn't actually asking for the height of the tree. It's asking if he's decorating the tree and does not have a ladder, how much of the tree is not going to be decorated? We're not going to get into specifics. We're going to just use his height. he can't go taller than his height without something to step on. So he can decorate anything from his height and below, but he can't go above his height. So we're going to kind of break this tree up a little bit. We know his height is 5. That's what was given to us right here. We're looking for this piece right here, this question mark. So it's segment addition. Really, this last step is just segment addition. You have to think about, well, if the height of the tree is 10 and he's 5, he can't decorate above that 5 feet. So how much of the tree won't be decorated? 5 feet of the tree will not be decorated.
Now, you do have quite a few problems like this in your homework. So pay close attention to what the information is that we are looking for. We could be actually looking for the distance that is found by using direct measurement, or we could be looking for information that you'll have to use indirect measurement to find a number to help get to another number. So just read very carefully. So, for example, in your homework you have a question about a man who is painting his house. I would refer back to this problem.
There you go. SpongeBob too.
Oh yes, when you do your SpongeBob problem, you'll probably want to look back at this problem and go, wait a minute, there's a couple of missing pieces here.
Yep. All right. So hopefully we portrayed this to be as easy as we hope you find it to be. Setting up proportions, just again, think about your columns and your rows. Make sure you're staying consistent in how you're setting them up. If you're going to say 2 ratios are equal, then they need to actually be equal to each other. So hopefully you're agreeing on that and you're feeling confident and able to at least attempt the homework. If not, you know how to reach us. Please make sure you are reaching out to us when you have some good questions for us.
Hey, Mrs. Weichel.
Hey, Weddy.
So, my birthday's on 11/11.
It is?
Yeah, but I also celebrate it on January 1st.
Why is that?
Because I know how to simplify fractions.
Because 11 over 11 is
1 over 1.
That's awesome.
Can you do that with your birthday?
I can't. My birthday is March 23rd, so I'm prime.
Oh, one birthday.
One birthday.
Bummer.
But it's prime.
No simplifying for you.
No simplifying.
Oh.
All right, thanks for joining us. We have one more lesson in Chapter 6.
6.6.